Hi everybody, this is Cassie from the Wood County District Public Library, here with another summer STEM video with our friends from Lubrizol. So today we are joined by Kurt and Carly, and I'm very excited to present another wonderful experiment for you. So I will let them introduce themselves in just a minute, but first of all, let's talk a little bit about our fairy tale tie-in. So I know most of you are familiar with Cinderella. In the story of Cinderella, at the end, the prince has to positively identify Cinderella based on only one piece of information, which is the shoe that he has that he knows fits her foot. This happens a lot in fairy tales. People have to identify something out of a variety of options. And this is actually a really good way to talk about some science stuff too. So I'm gonna let Kurt and Carly introduce themselves very quickly, and then we will jump right into our science for the day.
Hi everyone, I'm Carly Daniels. I just started as a process safety engineer at Lubrizol this past December.
And hi everyone, I'm Kurt Lentz. I just started as a process engineer about 5 weeks ago.
How exciting. Well, welcome both of you. I'm really excited to do this experiment with you today. So here's what we've got going on. Right here in front of me in these containers, I have 3 different white powders. I know that one of them is baking soda, one of them is cornstarch, and one of them is sugar, but I don't know which one is which. So Carly and Kurt are going to help me use what they know about these powders and how they react with certain liquids to do an identification experiment to see if we can use that outside knowledge to determine which powder is which. So go ahead, Carly. Help me out, because
I was just gonna say, I like printing out.
that's okay.
That might happen a couple times throughout this, so just bear with us. As Cassie had said, we know that we have sugar, cornstarch, and baking powder as our different solids, or baking soda, I'm sorry, as our different solids, except we don't know which one is which in each bowl. However, we can use what we already know about the powders and how they can react in different circumstances to be able to identify them. So we have 3 different liquids that we can use to test how they react, and this includes water, vinegar, and iodine.
All right, so I can also use my observation skills to help me. But for the purposes of this experiment, I'm going to pretend like I don't know anything about these 3 powders. Let's say I don't know what sugar looks like. I don't know what cornstarch looks like. I don't know what baking soda looks like. I don't know what they feel like. I don't know what they smell like. Let's assume I know absolutely nothing about these powders, that is. So if I was going to make some observations, because that's a really important way to start, right? If someone could tell me this is what sugar looks like, it might help me say, okay, I think I'm making my hypothesis, my educated guess, that that's the sugar. But let's use our chemistry to know for sure. So, and this is my first powder right here, and I'm going to describe it to you. It's very granular. It's kind of like sand. So it's made up of a bunch of different little crystals. And it does stick to my finger, but I can brush it off pretty easily. So that's my observation of the first powder. The second powder here, this one is finer than the first powder. So the little individual pieces are a lot smaller than the first one. And it also sticks to my finger, but it doesn't wipe off as well. I can get most of it off. But yeah, it's a lot more powdery than the first powder was. And my last powder here is even finer than this one. And it's actually so fine that it's kind of clumping together in smaller clumps. And if I touch this one does not like to come off my fingers. It's kind of sticking and getting in all of the little fingerprint lines that I have on my hands. And it's also important to say that the reason I'm touching these powders with my bare hands is because I know that they're one of these 3 powders and that they're not going to hurt me. But it's really important that if you actually don't know what something is, you probably shouldn't touch it with your bare skin because it might hurt. So that's an important safety thing to keep in mind. So those are my visual observations and my tactile observations. So now, Kurt and Carly, what can you tell me about the chemistry? What's going to happen when I combine liquids? What should I be looking for?
So for one example, the cornstarch, when you combine it with water, it's going to form a non-Newtonian fluid, and it'll act as a state of matter that acts as both a liquid and a solid under different circumstances. So it'll flow differently.
Okay, so I know a lot of the kids watching have probably made oobleck before at home. And that's how you make oobleck. You combine cornstarch and water. So when I combine water with whichever one of these is cornstarch, it's not going to act like a liquid and it's not going to act like a solid. It's going to do a little bit of both. So I know to watch for that. What else can I look for?
So then also with the cornstarch, when it's combined with iodine, it will actually turn black as you see the iodine gas or hydrates that are present in the cornstarch.
Okay.
So the black formation of that black color will let you know that that powder is indeed cornstarch.
All right, so when when a powder turns black, when I put the iodine in, I know that's probably cornstarch. Okay, so that's going to help me identify my cornstarch. How can I identify my sugar and my baking soda?
One thing about sugar is that when it reacts with water, it's going to completely dissolve and create a sticky solution due to the presence of hydrogen in the sugar's molecules. So
Okay,
it dissolves very easily in water.
so it's going to dissolve and it's going to be sticky. Good to know. What else?
And then you also have a reaction with baking soda and vinegar, which actually creates a gas called carbon dioxide, and you'll be able to see the formation of that gas because there will be bubbles that will appear after the reaction is complete.
Okay, so that is good information to have because I have a positive way to identify cornstarch and baking soda and sugar. So I know what I'm looking for. So here's how the experiment's going to work. I am going to get a new little plastic container for each test that I'm doing. So I have 9 of these because we've got 3 powders and 3 liquids. I am going to get the same amount of each powder each time. This little scoop holds 20 cubic centimeters. So we're going to do 20 cubic centimeters of each powder each time we test. And then I'm going to test against 10 milliliters of the liquid. Now, with an experiment like this, it probably doesn't matter as much that we keep all of our amounts consistent. It's not as important as it has been in past experiments, but it's a good habit to get into when you're testing different variables because you want to be as consistent as possible. Right, Kurt and Carly? We've talked about that with the scientific method before.
Absolutely.
Yeah.
All right, so I'm going to do all 3 of my first powder tests in a row, and then we'll move on to the other powders. We'll see what conclusions I can draw to make my determination about which one this is. So I've got my 20 cc's of powder A, which I'm going to put in there. I'm being really careful to avoid something called cross-contamination while I'm doing this. So I've got a different scoop for each powder because if some of the other powder's residue is stuck on my cup and I use it to dip out another powder, what might happen when I'm looking for those reactions? I might get a little bit of the reaction, even though it's not the right powder, but because there's just a little bit of it there. So we want to be really careful to make sure everything stays in its own container. So I'm going to test with the water first. I'm going to measure out 10 milliliters right here. I'm going to pour it in, and I've got a coffee stirrer that I'm going to use to kind of stir this together. All right, so here are my observations. It is starting to dissolve. I'm not sure I have enough water to make it dissolve all the way, but I can definitely tell that it's starting to dissolve. And you said that sugar and water would be sticky, right?
Correct.
All right, so let me test that here. Oh, that is pretty sticky on my fingers. So there's a good chance this first powder is sugar, but let's keep testing just to make sure, because the more information we can gather, the firmer our conclusion will be. So we're going to do another scoop of powder A. And this time we're going to do 10 milliliters of vinegar. So remind me what reaction I'm looking for with the vinegar.
So if you have vinegar and baking soda, you will create bubbles because of the carbon dioxide forming.
All right, so I'm looking for bubbles, and that'll tell me this is baking soda. I do not have any bubbles. No bubbles, so I think this is probably not baking soda. So now let's see if it might be cornstarch. Oh, yep, it's definitely sticky now as the water's evaporating off my hands and just that powder residue is left. All right. One more scoop of this powder. Now, if you've never heard of iodine before, it's something called an antiseptic, which means that it's really good at killing germs. So it's used in a lot of first aid. And it is naturally this kind of dark brown color, right? But you told me that when this combines with starch, it's going to turn what color?
Black.
Black. Okay, so I'm looking. So I think that it's going to turn colors regardless just because of the color of this liquid, but I want it to be black, right? Here we go. All right. So it's definitely changing color, but I'm pretty sure it's just staying the color of the iodine itself. I don't think it's turning black, but we'll have the other options to compare to. All right, so those are my tests for powder A. Based on this evidence, it's not turning black with the iodine, I don't think, but we need to do some comparisons later. It didn't make bubbles with the vinegar. It dissolved in the water and turned sticky. So based on that evidence, I think my hypothesis is that powder A is sugar. You guys agree?
Completely agree.
I'd say so, yes.
All right, so that's our guess for right now. And if we get more data from these experiments that contradict it, we can work that in. So now we're on to powder B. Again, we're gonna do 20 cc's here. We're gonna do 10 milliliters of water. Not that much. Okay, pouring it in. So again, with our water, what we're testing for is, does it dissolve and does it go sticky? This is not really dissolving, it's just kind of turning gloopy. You can kind of see that there as it drips into the container. But it's not really dissolving, it's just making kind of like a sludge. Is that a scientific term?
Sure.
Sure, okay.
We actually use the term sludge at the plant, so I'd say so.
Perfect, excellent. So, science, absolutely. So, testing it with my finger, it's kind of gritty. It feels like at the beach when you get a handful of sand from under the water, but it's not turning sticky. So that was my water test. Now we're going to test with vinegar. And so I'm looking to see if this makes bubbles when we combine it with vinegar. And that will tell me, if it makes bubbles, it'll tell me it's which powder?
If it makes bubbles, it would be baking soda.
Okay. So here we go. I don't know if you can hear that, but that was definitely some bubble action.
Looks bubbly to me.
It looks bubbly, it sounds bubbly, it feels bubbly because it kind of sprayed up a little bit. Yeah, definite bubble action, definite what? No, carbon dioxide creation. That's what I'm trying to say. All right, but even though we had that reaction, let's go ahead and do our whole test it with the iodine just to see what result we get. So here's our 20 cc's of powder. Bring over our iodine. And milliliters of that. And I'm waiting to see if it turns black. So again, it's definitely keeping the color of the iodine, but it's definitely kind of brown. Kind of tip, you can see on the bottom, it's a little easier to see the color there. So I said I wanted to compare it with my first one, right? Oh, here we go. I don't know if you can see, but this one is definitely darker than this one.
Yes.
I don't know if I'd call it black, but I think it's darker than brown. Well, that's an interesting development. We'll talk about that more in a little bit, but for right now, let's go ahead and test our, well, let's talk about these results. So I'm pretty sure this one is sugar. Here, when I mixed with water, it's not sticky. I can feel that on my fingers now. I've just got the like grit of the powder left now that the water has evaporated. So it's not sticky with water. It did create carbon dioxide with vinegar, and it has not turned black with the iodine. So my hypothesis is that powder B is baking soda. Do you guys agree?
I would agree with that.
I would also agree. The bubbles convinced me.
All right, so let's test our last powder and see if it gives us some conclusive evidence. So again, we're going to get 20 cc's of powder and 10 milliliters of water. Combine that and then stir it together. If it's sugar, it'll dissolve. If it's baking soda, it won't dissolve. And if it's cornstarch, it's going to create that non-Newtonian fluid. And I got to tell you, it's kind of becoming hard to get my stick through this. It's like when I put pressure on it, it's acting like a solid. But when I take the pressure away, then it acts like a liquid.
That sounds like a non-Newtonian fluid to me.
Yes, it does. Okay, so that's good to keep in mind. Let's continue with our last two tests and see if we can draw any conclusions. So 20 cc's of powder, 10 milliliters of vinegar, we'll stir that up here. Well, now it's kind of doing the same thing with the vinegar that it was doing with the water. Does that make sense scientifically?
Yeah, it can have the same type of reaction. There might be a lot, I don't know how much water there is in vinegar.
Well, let's see here.
Vinegar is like milk.
Yeah, this is reduced with water to 5% acidity is what it says on here. So there is a lot of water in vinegar. So you're right. I think it makes sense that this is reacting similarly to the way it reacted with water. But what's important is there's no bubbles. So we're not creating carbon dioxide with this. So if this is cornstarch, which if this is sugar and this is baking soda, then this is cornstarch. If this is definitely cornstarch, then with the iodine, it should turn black, right?
That's what should happen.
All right, so here we go, pouring it in. Stir this up. Oh, yep. That is completely black. That's not just brown. That is all the way black. Okay. But here's what's interesting. My sugar is a lot darker than my baking soda because I think we've correctly identified this is turning black and creating non-Newtonian fluids, so this one's cornstarch. This one reacted with carbon dioxide, so it's baking soda. And this one dissolved in water and turned sticky, so it's sugar. But I'm really curious about this iodine combining with the sugar because it's turned a lot darker than the iodine that combined with the baking powder. Is there a reason why that might be true?
Well, a lot of substances are not pure substances. There are impurities involved. So there might be some impurities in any one of these substances or anything that you encounter that will provide a reaction that you may not be expecting.
I think that's right. I think that this is telling me that maybe part of sugar is starch like or very similar to the cornstarch. And this gives me a new question that I can go do more science experiments about. So that's pretty exciting for me.
There's always more experimentation that you can do.
Yes.
Absolutely. So you start out doing one thing and you get a conclusion that makes you go, well, that's interesting. And it leads you in a brand new direction. So
It
what
happens every day here.
good, it's good to know. So
You get
here's
as many questions as you do answers in a lot of experiments.
Yes.
absolutely. So here's my question for both of you now that we've done this experiment. One of the things that we did before we started is we said, okay, here's the knowledge that we already have. I didn't have to go do another test before this to prove that baking soda reacts with vinegar. We just said we already know that that's true. How does an experiment like this communicate to the real world and the science that you might do at Lubrizol? How does this match up with some practices that you engage in your work?
So we make soap essentially, and to send out the soap for customers once we make it, we want to make sure it is going out as pure as we say it is. So we do testing to make sure those impurities that might show up are not present, and we also want to make sure that it's safe for our customers. So we want to make sure that there isn't anything in the product that might harm the end user. So both safety and quality of the product depends on these kind of identification tests.
Fantastic. Any other real world applications?
What's that?
All right. I think it's also important to remember that people have been doing science experiments for a really long time. And so there are some things that maybe we can't say 100% they're proven, but we can be 99% sure they're true. And so we can build off of the research that other people have done before us, right?
Yes.
Absolutely.
We use so many resources, and each of the things that we do each day, whether it be literature or somebody already at the plant who has been here for a few years, and we just take what they know and then build off of it, and it continues on in that cycle.
That's wonderful. Well, thank you, Kurt and Carly, so much for joining me today. This was a lot of fun, but as always, I've got some cleanup to do.
Thank you.
Thank you.
So we will hopefully see you next time.